Alright guys, was there any questions on yesterday's assignment? I know you just handed them in. No? Okay, we need to be on 7.2 today. Okay, we're talking about reflections. Just like I told you, we're going to take our 3 transformations that we learned yesterday, and we're going to split them into 3 lessons the rest of the week. You do have a quiz on Thursday. Okay? So first of all, what was one transformation that we learned yesterday, Matthias?
Reflection.
A reflection. Laney, what's another one? Rotation. And the last one, Austin? Translation. That's all I have for you. Okay, so those are our 3. And all of those are what? What was that other word we learned? Isometries. Okay, those are all isometries. Remember we went over that yesterday. Thanks. Okay. Now we have a little bit here for vocab today. I'm going to skip the first one. The first one is reflection. We know what a reflection is because we learned it yesterday, right? Okay, basically it's just a mirror image. Okay. Now I want for our first definition to be line of reflection. Line of reflection. Some of us are probably going to be able to think about this and realize what that is. What is a line of reflection going to be? Royal? Right, the line we reflect over, right? Yeah, exactly. Okay, the line that you reflect something over. It's the line you reflect something over. Now it does have to be a line, so you got to keep that in mind. You can't reflect over a point. That doesn't make any sense. You got to reflect over an entire line. Okay, so if I have this line L, and I have segment AB, should I be able to reflect that over line L? Yeah. Okay, so figure out, make sure you're getting pretty close to your distance. That point would be called what? B prime. This point would be called A prime. And that would be our reflection. Again, I can't expect it to be 100% perfect, but you do need to do your best at that. Okay. So our line of reflection would be what, Taylor? Line L, good. Alright, now the next thing you come to in your book with example 1, you're basically doing the same things, except now it's on a coordinate plane. Okay, so with this, they're going to give you a point. Okay, maybe it's right there. That's point A, let's say. Actually, I'm going to move that a little bit. Let's go over here. Okay, that's point A. They want you to reflect point A across the line x equals -1. Now, we talked about this yesterday. We have to understand, where is this line at? And what does it look like, Jacob? This one's going to be vertical. Where at? Right there, right? How did he know it was going to be vertical? What does x equal right here? It's -1, 0, right? That point. What's this point? -1, -3. This one? -1, -6. This one up here? -1, 4. Hey, what are all my x's right there? X equals -1 everywhere right there, right? Okay. So that is the line. That's a good way to check if you have that line correct. That's x equals -1. Okay, because x always has to equal what? -1. No matter what your y is, your x is always going to equal -1. Okay, so I have my line there. X equals -1. Travis, how am I going to reflect A across that line? Good. So count the space between the line and the point. So 1, 2, 3, 4, 5, 6. Good. And then match that on the left side. 2, 3, 4, 5, 6. And then that point is going to be called A prime. Okay, not too bad, right? The hard part there is making sure you reflect it over the proper line. Okay, remember this is what? The x-axis. This one is the y-axis. Okay, keep that in mind. Now the other thing you're going to come across, and I don't know if you've ever learned this before or not, okay, but you're going to come across a line that comes right up through here. And they're going to ask you to reflect across that line. Okay, that line is the line y equals x. Okay. Now a lot of people, even when we're graphing, some people have trouble with this. Okay, but that line is actually y equals x plus how much? If we're adding, wouldn't it be there? If we were adding 1, wouldn't it say plus 1? Plus 0. Okay, because we're not adding anything, right? Okay, so that y equals x is actually the same thing as y equals x plus 0, correct? You guys remember slope-intercept form? That's in it, right? What's the y-intercept? 0. Do I have that? Yeah. Okay, what is the slope? 1. From my y-intercept, do I go up 1 over 1? Yeah. Okay. So this is the same line as y equals x plus 0. Now, another easy way to remember it, and the way I have always remembered it, what does y always equal? X. So if y is 1, what's x? 1. If y is 2, x has to be 2, right? Because they're always the same. If y is 3, x is 3. Okay, if y is -99, x is -99. Okay, they're always going to be exactly the same. You're going to have to know this. I know you have it on your assignment today. I'm pretty sure you run across it on your quiz, and I know it's on your test. Okay, you're going to have to know what the line y equals x is. Okay, now you got to figure out, how do I reflect A across that line? Okay, well, I can't count actual units anymore, can I? No, but can I still count diagonally, Travis?
We have Jacob while you're on, pick up the phone, please.
Yes. Can you still count diagonally, Travis? Yeah. So, but you're going to go one diagonal and then a half, right? Okay, so you're going to go a half and then another one. Okay, and maybe we call that a double prime. Yeah. Yes, that was the other thing. Okay, if you have, then notice this point is 5, 2. When you reflect over the line y equals x, what happened? You get 2, 5. You just switch them. Okay, that'll always work in y equals x if you're reflecting over the line y equals x. Okay, because if let's say I'm here, I'll erase this in a second. Okay, but I'm 1 1/2, and I go 1/2. Notice this is -2, 1. Down here, you're at 1, -2. Still switched, right? Okay, so that's another good way to remember it if that's how you want to do it. I personally just like to count, okay, but if you want to just switch coordinates, that's fine as well. They just might not always give you the coordinates, so you have to find them, but that's not a problem. You guys all know how to count coordinates. Alright, now the other thing we have here, you look down below, they do give you a theorem here. Okay, if you want to write that theorem on your theorem sheets, feel free to. Okay, but I'm not going to tell you that you have to, because all it says is that a reflection is an isometry. Didn't we learn that yesterday? Yeah. Every single transformation that we're going to talk about is an isometry. Okay, so if you want to write that down, you can. I don't think that you necessarily need to, though. Okay, now, one of the more confusing things that we're going to talk about today, and it's not bad, okay, but it's a little bit more difficult than this last stuff, is finding a minimum distance. Okay, and this isn't necessarily a minimum distance between 2 points. Okay, it's a total minimum distance of 3 points. So you're going to have, the example that they actually give you in your book is they say you have 2 houses. Okay, maybe they're new houses. They must be new houses, because what they're trying to do is they're trying to run telephone wire to these houses. Okay, so maybe they're new houses and they got to figure this out. Well, when you run telephone wires, telephone poles are usually alongside the road, right? You guys agree with that? Okay, so there's our road. Pretty good looking road. Okay, but they're not going to be on the road, right? You guys agree with that? You're not going to put the telephones in the middle of the road. It's going to be a little bit off. Okay, so there's where our telephone poles need to go. Somewhere along there. Their goal is they're trying to figure out where on this line can I place a telephone pole so I use the least amount of wire. You guys get what I'm saying? Okay, and there is one specific spot. A lot of us, when you look at this, you think, well, it doesn't really matter. I should be able to move this point anywhere, and it's the same amount of wire. Okay, it's not. It's kind of deceiving. Okay, some people in the last class said, well, if you move it one that way, then you lose one here, but you gain one here. That's not accurate because of the angles. Notice this side is not the same as this side. Okay, so it doesn't work like that. Okay, so what we're going to have to do to find our minimum distance, we're going to pick one of our points, either A or B. Doesn't matter which one. I would suggest A because it's a lot closer to this line. Okay, so we want to pick A, and we're going to reflect it across this line. Okay, once I do that reflection, what's this point now called? A prime, good. Okay, and then from there it's really easy. There's really only 2 steps here. Reflect a point, and then connect that new point with your other point. Where do you suppose our point C needs to go? Right here where it intersects. Right there, that's going to be point C. Okay, so what that actually ends up giving us is it gives me the shortest distance from A to C, then C to B. Now, a lot of people in the other class, they're like, well, so what? What? I don't care. Like maybe, so they have to use a little bit more wire. Okay, that's not the only way or place that this can be used. Okay, honestly, I would say one of the biggest uses to this possibly is like big companies, corporations, trying to figure out. I think maybe it was in this class we did a problem with where a warehouse was going to go. You guys remember that problem earlier in the year? Like trying to figure out where. Well, wouldn't this be a good way also? Trying to figure out the shortest distance total. If you had to travel from this to here and then up to here, okay, maybe you got to deliver things. Okay, you don't want to be flying an airplane or driving a long ways. You want to cut that distance to a minimum. Okay, so that would be another example where we could use something like this. Okay, so step 1, you reflect one of your points. Step 2, you do what? Connect your new point with your other one, right? Okay. I'll do an example here on a coordinate plane, and I'll show you that it doesn't matter whether you reflect A or B. Okay, so the next one, and the ones that you're going to have to do in your homework are going to be on a coordinate plane. Okay, so they're going to give you 2 points, just like what we just did. They're going to give you that one, and maybe this one here. Okay, we'll go A and B again. Okay, so you reflect A, and you get A prime. Yeah, they want to know what's the minimum distance to the x-axis. Where's the point that gives you the minimum distance to the x-axis? Okay, so you reflect over the x-axis, draw your line. Oops, not like that though. Oops, not like that either. There we go. Okay, and then my point should probably be, looks to me like it's probably, if I had drawn it perfect, at -4, 0. You guys agree with that? Okay, so this plus this would be at the shortest distance at -4, 0. Okay, again, it shouldn't matter if you do B though. Okay, let's do B in blue real quick. Let's reflect that. If I brought that down here and then drew my line, do I end up in the same place? Yes. Okay, so it doesn't matter which point you choose. If you use a different one than somebody else, that's fine. Okay? It doesn't matter which one you use. You'll get the same answer either way. Questions on what did we just find there? Minimum distance. Okay, you're gonna have 5 problems that talk about it, 2 where you actually have to solve it. Okay. All right, flip the page. We're on 406. You got one last thing we really need to talk about here. That is the line of symmetry. And it's just a definition. We kind of, I'm guessing, have an idea of what a line of symmetry is, right? Somebody explain that to me. So it's the line where you cut something and it's exactly the same on both sides, right? Okay, so what we decided last class is the best definition for this is a line which cuts a figure into 2 identical parts. Does that work? Does that make sense? Hey, some people have made the comment that it cuts it into 2 equal parts. Can I have 2 things that are equal but not identical. Can their areas be the same? Yeah, and that would make them equal, right? Okay, but maybe they're a different shape. Okay, they have to be identical. They have to look the same and be equal. Okay, so taking a look there on example 4. Okay, part A. Okay, that particular hexagon has only one line of symmetry. Okay, because it's not a regular hexagon, right? Okay, so you got to be careful. If it would draw it horizontally, it wouldn't make identical parts, correct? Okay. Part B, B is kind of hard to tell, but that shape is elongated. Okay, so it's stretched out. That's why there's only 2. Okay, so you can't go from corner to corner on that one. Yeah, everybody see that? Okay, and then when you have a regular figure like part C, how many options are there? There's 6 in that one. Okay, what about on just a regular sheet of paper here? How many lines of symmetry? Okay, you could fold it, what's this way called? Hot dog style. Okay, that's one, right? And this way? Hamburger style. I don't know why they call them like that, but I guess. Okay, right there, right? Why does this not work? Corner to corner? Yeah, it's not exact same on each side, is it? Okay, because we got overlap here. Okay, so that's another way to think of it. If you could fold it in half, is there going to be anything that overlaps? Because if there is, it's not a line of symmetry. Okay. I know that was not super long. Okay, are there any questions on any of that though? That's going to be pretty similar to what our lessons are going to be like for most of the week, because now we're just going back and talking more about what we did yesterday, right? Okay. So, your assignment. Yeah, a few people have got this done in class. Hey, you are going to need one sheet of graph paper for this. A big sheet of graph paper. Okay? I'll tell you which problems you need it for. The first 2 you might want to look at it on graph paper, but it doesn't actually want you to do it on graph paper. Okay? But you're going to need graph paper for 26, 28, and 37 through 40. Okay, that's on graph paper.